Right, we got just one more example. Here it is. All right. Find the volume of the solid bound by this region, y equals -1/2 x plus 2, y equals 0, and x equals 0. So think of that as the base, whose cross sections perpendicular to the y-axis are isosceles right triangles with one leg on the base. So from that base, from that region, the cross sections, isosceles right triangles, so that means two sides of the same length, with a right angle, with one of the legs on the base. Okay. Here we go. Cross sections perpendicular to the y-axis are isosceles right triangles with one leg on the base. All right, that's a lot to take in. Let's draw it. Let's start with the region. So here they give us equations. So we know already there'll be an XY plane. Let's see, this will have a y-intercept of 2, slope of -1/2. So where would it hit the X? So if it goes down 1 over 2, down 1 over 2, and that's at 2, then we'd end up at 4. Okay, so grab a straight edge for this. There's our line. And then, so that's y equals -1/2 x plus 2. And then we also have y equals 0 and x equals 0. So the region is this triangle. Okay. But then it says cross sections, they run perpendicular to the y-axis. So they're going to come off this way. And that will form an isosceles right triangle coming up where this is one of the legs. So we're going to say, what would that look like? All right, there's that same line. It's an isosceles right triangle. So this is one leg, here's the other leg, here's the right angle between them. You get the idea. So that is that line there. Okay. Again, right, what's our goal? We know what we're trying to do is figure out the cross-sectional area, the function that describes it, a of x. We can do that. If we can find the cross-sectional area at any location, then we're all set. Hey, you know what? As I look at this shape, we're looking at these cross sections, or these bases. They're moving up the y-axis. We're going to need to integrate with respect to y, since those lines are moving up the y-axis from 0 to 2. So, okay, integrating with respect to y, moving vertically, we're going to have to rewrite our function in terms of x. So instead of y equals -1/2 x plus 2, let's see, we solve for x, subtract 2, multiply by -2, we'd end up with -2y plus 4. So it's actually all going to be in terms of y. Okay. Let's think here. If we can figure out this length in terms of y, then we can figure out the area of our triangle. What is this length here? Well, notice we're coming off the y-axis, moving out. If this here is the point xy, then that distance is the horizontal, that's x. And we found what x equals already. It's negative 2y plus 4. So the base of our triangle over here is that x, it's negative 2y plus 4. So what would that make the area? Well, negative 2y plus 4. That would mean, since it's isosceles, the height is also negative 2y plus 4. The area of a triangle, 1/2 base times height. It's 1/2 negative 2y plus 4 squared. We got it. Figured out the length of that line. Then the area of our triangle, 1/2 base times height. Boom. Let's multiply this out, since we're going to have to integrate in another minute or so. See, that'll be 4y squared minus 16y plus 16. And then the 1/2 going through 2y squared minus 8y plus 8. So the volume will be the integral. And what are the limits? We're doing y, right? So 0 to 2. For our area, dy. Once you have it set up, well, you're pretty much home free. Get that antiderivative and evaluate. Plugging in 2. Plugging in 0 again gives us 0. That's always nice. So what's our final answer? Two-thirds times 2 cubed minus 4 times 2 squared plus 8 times 2. I got 16 over 3. Okay. You know what I didn't do this time was check that area. Let's do that for different values of y. Kind of like to do that myself. Let's say when y equals 0, what would be the area of the squares or the triangle? So the base would go all the way out to 4 and then come up and make this triangle right up off the page. So if that base is 4, 4 times 4, 16 times 1/2 is 8. Hey, if we plug in 0, will we get 8 for the area? Yeah, 4 squared times 1/2. Yeah. Hey, what about when y equals 2? That should give, then the base is 0. That should give an area of 0. If y equals 2, do we get 0? Yep, negative 4 plus 4. And it'll be true for any other y value in between. You can figure out the area of the cross section by plugging in the y. And then doing that integral, it's adding up all of those area times widths. We end up with the volume. Very nice. All right, you guys, that's it for general volumes.